So first off, what I want to do is let people know what I'm intending for the next two presentations. So in this presentation and the next one, I'm going to do a kind of high-level conceptual overview of some structural engineering concepts. Um, and the reason I'm doing this is to try and fill in some gaps for some people that might not have this kind of background, specifically people who are machinists or welders or artists. So I actually have a significant amount of machining and welding formal experience. I actually took courses in these things at a local community college when I was in high school. And while I was doing that, I actually would get questions from the machinists asking if we ever learned in our kind of advanced calculus or science classes how to predict what the deformation of a structure would be under some load. And at that time I didn't know anything about it because they don't talk about that in high school. But I knew that the machinists were interested in this kind of knowledge. And so for this reason I'm going to go over it a little bit in the next presentation. Just so you know, I'm going to be a little bit high level with this, actually very high level. Sometimes I'm a little bit fast and loose with terms. If you need to know details on some of the structural engineering terms I discuss, there's always solid mechanics texts, and there's a number of presentations on YouTube that are more like what your formal engineering solid mechanics education would look like. So I'm going to refer you to that for this. The purpose of my presentation is more to give you a very general, high-level conceptual idea of some structural engineering concepts. So just be aware of that up front. So with that, I kind of want to talk about two of the major structural failures that are experienced. There's many different kinds of structural failures, but for the purpose of this presentation I'm going to focus on two of them. And these are going to be strength versus stiffness limits. And first we're going to start off with strength limited type designs. So when you have a strength or a failure due to strength, like lack of strength I guess is how you'd say it, typically what ends up happening is your structure is put under some load, and as a result some portion of the structure experiences a permanent deformation after the load is removed. Alternatively, it may be the case that actually part of your structure actually breaks apart or becomes separated from itself. So as an example, this is one of the race cars we built when we were in college, and you can see here it drove into this curb and then it hit this tree, got wrapped around the tree, and this is kind of the aftermath. And this is a composite chassis here, composite monocoque, and this is a good example of a failure of strength. You can see this thing is clearly permanently deformed here, and the monocoque is broken into two pieces at least essentially here. So this is a good example of a failure of strength. And I think a lot of times when people think of structural failures, they think of strength failures, but it turns out that these aren't necessarily the most important things to be concerned about. So with that, what I want to talk about is failures in stiffness, which actually in many cases are more important to be worried about. So a stiffness failure is when maybe the members in your structure have a load applied to them, and they don't necessarily break apart or permanently deform or bend, but they might deflect. Maybe not permanently deflect. They will probably return to their original shape after the load's removed, but they deflect quite a bit. So here's a good example. This is my friend. He's standing on this board here, kind of a skinny board, and you can see it's noticeably deflected. And I would consider this a stiffness failure. The board hasn't actually broken apart. It's supporting his weight, but it's clearly deflected. And you can think about it, if you had a porch, and your porch it had members of this manner that every time you stepped on it, it clearly deflected, or every time you put your barbecue grill on it, your porch bent, you probably wouldn't be happy with the quality of your porch. So it turns out that many times you're really more concerned with building structures that don't experience stiffness failures as opposed to strength failures. And if you look at the details from a solid mechanics point of view, it turns out that oftentimes, not always, but oftentimes, if you design your structure so that it's stiff enough to experience acceptable deflections under load, it's probably going to be plenty strong enough. So if your structure just deflects at a very small amount when you apply load, it's probably going to be plenty strong enough to deal with the loads you're applying. So there's many caveats to that, and if you want to learn about them, you're going to have to go to engineering school. But that's kind of where we're coming from here. So let's see. With that, I want to give some idea of how stiff the components of the barbecue grill are. You know, something like a barbecue grill is going to have many components that are going to be stiffness limited. You want to design them to experience the minimal amount of deflection. So to do that, what I did was I started looking at what the thickness was of the sheet metal used to build the barbecue grill. So I pulled out my caliper and I measured the sheet metal on the lid of the barbecue grill, and it turns out to be about 50 thousandths of an inch thick. Now, I didn't have any 50 thousandths inch thick steel in my garage, but I did have 40 thousandths and 70 thousandths inch thick steel. Now, if you look at this is a 40 thousandths inch thick steel plate. I'm holding it, and you can see it's clearly deflecting under its own weight. So this plate is not necessarily that stiff in and of itself in its normal sheet form. And if you look even at 70 thousandths thick steel plate, in this case it's 3 inches wide, and I have my framing square here, and I'm loading it with this C-clamp. You can see this deflects a couple of inches. So in its normal configuration, these materials are not necessarily that thick or stiff. But if you go to your barbecue grill and you start pressing on it, it's not going to deflect like this. So this gives you some food for thought. So with that, I'm going to stop here. In the next video, I'm going to talk about pure bending. Thanks. Bye.